In this video, we will be creating this little character that can move in all directions, and we'll be adding some movements to our camera so that we can fly around our character and still move it correctly in all directions as we want. You will notice that the player is not rotating in the direction of the movement. This will be left for a separate video. So until then, let's start creating this from scratch. Let's start by creating a new scene. It's going to be a 3D scene. We can just call it main. And we will first add a floor that we can walk and move on. So let's add a node. It's going to be a static body. And here it says we need a shape. So that's a nice thing about Godot. It's going to tell us what we need. So let's add a shape for collision so that we can walk on it. It's going to be a box, and we can just make it 10 by 10 meters wide. And we also need some mesh on it. So let's make a mesh, and that's also going to be a box that is going to be 10 by 10. So we can just call this floor. And now we have something to walk on. Now if I press play and set this scene as the main scene, and then we have nothing. And the reason we have nothing is because we don't have any lighting in our scene. So let's add environment to have a sky, and we can add a sun or a directional light. So now if I press play, we still have nothing. Why is that? Well, we don't have a camera. So if I quickly add a camera to the scene and lift it up and press play, now we can see our scene from the perspective of the camera. Now, we don't want to do this. We want our camera to be on our player so that when we move, the camera will follow along. So let's delete this camera, and we're gonna make a scene for our player. So let's make a new scene. Is going to be a character body 3D. So this is a pre-made object in Godot that will have some built-in functions for us to use and move our character more easy. So let's just call this player. And this also needs a shape. So let's add a shape. So collision shape. And it's gonna be capsule. That's very common. And let's make our character 1.8. So it's a common height. And then radius, let's just make it a bit more narrow. Maybe 0.4 will look fine. And we want our capsule to be centered in a way that its bottom is on the ground level of our scene. So we have to lift it by half of the height. So it's going to be by 90 centimeters. So if you go to transform and position Y, we can just do 0.9, and now the capsule comes up and it's standing on the floor. So if you look at the top right here, you can see this gizmo, which shows us our axis of the world. And in Godot, the Z axis is the forward-looking axis, but it's the negative Z. So this is our forward direction. Let's add some visuals to our player so that we can actually see it. And we can do that by adding another mesh. And let's say it's also going to be a capsule, and it's going to be the same height and the same radius. And then, of course, we got to lift it up as well as we did with the shape. So now the collision and our mesh match. So that's going to help us with collision around the world. And we have something to look at. And let's say this is the body, so we can just call this body. I want to add also some sort of a forward-facing visual so that we know where the character is looking. So let's say we want to add also another mesh instance. And let's call this head, and we'll just say it's, let's say this could be a sphere. We could put it up on top, half the size, and put it out, and then it looks like a character from Among Us. Actually, let's just make it a bit wider like so, and have it look like this. So now we know where the forward-facing direction of this character is. Let's put everything that has something visual to it under its own root. So let's make a node 3D just to put it all under that. We can call this visuals, and we're gonna put our body and our head in it. So now if I rotate the visuals, both the head and the body move along with it. And to make this a bit more interesting to look at, we can add some material to our mesh. So if I go to surface overrides, add a material, then we can just put an albedo color to it. And let's say we want to do like a reddish color, something like this. And then for the head, or maybe we should call this visor instead. And let's also put a material on that and put some let's say bluish color. Yeah, this is okay. So let's do that. And maybe I'm just gonna make it look like glass. I'm just gonna pull this down to 0.1, and now you can see the sun is also reflecting off the visor. So let's save this scene as player, and then if you go back to our world, we can now put our player in this scene. And if I press play, nothing happens because we didn't add the camera to our player. So let's add a camera as well. So add a camera, and since it's a third person, let's say we want to look at our player from up here, and then go back to the main scene, press play, and now we have our player. Of course, we cannot really look around or move right now. So let's fix that by adding some scripts. So let's go back to our player and add a script by adding a new script. We can call it player, press create, and I open my code in VS Code, but you can use the built-in editor from Godot, that's fine. So the way we get input events is by using a built-in function called _input, and it gives us an event, which is type of input event, and then we can check if this event is of input event mouse. And here we have a couple of options, and we are interested in the motion. And then let's just print event to see what kind of data we get from this. So if you go back and press play, if you look at the console, you can see that there are a couple of different things we can get from our event, and the one we're interested in is relative. So you can see that as I move my mouse left or right, we are getting negative or positive X and also negative or positive Y. So we can use this to add some movement to our camera. Let's talk in terms of pitch and yaw. So pitching means going up or down, and yawing means going left and right. So let's yaw our camera by using the X of the input. So we have relative.x, and we have also relative.y for pitching. So let's first define a variable for mouse sensitivity, and let's just keep it at this for now. And then we also want to get a hold of our node of our camera. And the way it works here is by using this syntax. On ready, we call our camera, that's our variable. We have to specify what type of node that is, so it's a camera 3D, and then to get a hold of this specific node by name, we use the $, and then we write name of that node. So this one is called camera 3D, so we just write camera 3D. If we called it camera blah, then we would write camera blah. So let's just keep it as the default names, and then under this input code, we can rotate this camera by using camera.rotation.y. And remember, the y-axis is the green axis here. So you can see if I rotate left or right around the y-axis, that's our yaw. So we can say that rotation y is equal, plus equal, and what that does is simply add to whatever the actual value is at the moment. So if I say +1, it's gonna go from 0 to 1, and then it's gonna from 1 + 1 to 2, etc, etc. So here we wanna add that relative mouse movement. So it's event.relative. Now here it's not y, it's actually x, because x is the left and right movement of our mouse. So if I save that and go back to our game and press play, we can see now that, well, there's definitely movement, it's just glitchy AF, and that's because we forgot to also multiply that relative movement by our mouse sensitivity. So let's just add mouse sense, save, press play again, and now you can see we have much smoother mouse movements. And if we do the same for pitching, so I'm just gonna copy this code, and we're gonna say rotation around X, that's gonna be our pitch, and we're gonna use data from the Y axis of our mouse. And if I press play now, we can move our camera around the scene. It seems that my movements are inverted, so when I go right, the camera goes left, and when I go up, the camera goes down. So it's a very simple fix. We just change these pluses to A-, and if you start again, we can see that we are now having correct movements. Now, one thing that you notice is that my camera doesn't move until my mouse enters the screen. And to fix that, we can do something else on the onReady function. So _ready is another built-in function from Godot. So once the player loads, we can say input.mouse mode is mouse captured. Now you'll see our cursor disappears, and I can move as much as I want without the mouse leaving the screen. Now, usually in third-person games, we don't just rotate the camera. We kinda wanna rotate around the player. So let's fix that by adding a spring arm instead of just manipulating the camera. So back in our player, I'm just gonna reset our camera position by pressing this icon, and then we're gonna add a spring arm. Then we're gonna latch our camera to that spring, and what a spring arm is literally what it says. It's an arm that extends a certain length, which we can set under spring length. So let's just say 3 meters, and in our code, let's not forget that our camera is now nested under spring arm. So we have to write spring arm 3D here to get the camera axis. And then if I press play, now our camera is 3 meters behind. However, we are still rotating the camera instead of the spring arm. So let's fix that by, instead of rotating the camera, let's grab a hold of the spring arm instead, and then we're gonna rotate the spring arm instead of the camera. And now if you press play, we get nothing, because as it says here, it's actually very important that you can read these messages. It says we are trying to assign a value of type spring arm to our variable that is a camera. And we can see here that we grab hold of the spring arm, but the type is still a camera. So let's change this to spring arm and try again. So I want it to be rotating around the eyes or the visor of our player. So if we go back here and we just raise this spring arm a bit up, let's say somewhere around the eyes area. Now we have our character and we can move our spring arm with the camera latched onto it around our player. So this looks nice, and all we have to do now is add some movement inputs so we can actually move around the scene. So to add inputs to our character, first we have to map those inputs, and the way we do that is by going to Project Settings, and then if you select Input Map, we can assign some inputs here. And I've already assigned my WASD keys and space to left, right, forward, backward, and jump, but you simply press here under New Action. Let's say you want to have shoot, you add it, then you press this plus icon, and you can select which kind of, you can even press a key, it's just gonna auto-select it. Or if you want to have a mouse click, you can go under mouse button and assign it to a button click. I'm just gonna delete this one, and I'll have these 5. So if you want to copy those, you can follow along. And then, for example, there is this input is action pressed, and if you hover over it, it's gonna say what it does. So if instead of this, I use my jump, if I go back to the game, if I press space, our character can now jump. Now, this code has been pre-written in the character body 3D, so that's why it works straight away. However, our WASD keys aren't doing anything just yet, because we gotta write some code for that. So if you look at this code for input direction, we can see that there is this input get vector. And what this does is basically constructs a vector 2D based on the action inputs that we've defined before. So our inputs are called left and right and forward and backwards. So if we pass those in, we get a vector where the x is gonna be dependent on whatever we pass in these two, so our left and right, and then our y's are gonna be dependent on forward and backward. I'm gonna print input here, and then you will see what happens. So when I press forward, we are getting -1 in the y-axis, and when I press backwards, it's 1, and left and right gives us the same in the x-axis. So we can use this data now to move our character in those directions. The way we do that is first we construct a 3D vector. So this is the 3D vector, and we feed it data from the input direction. So the x is our left and right direction, and that's already mapped correctly. So x from 2D vector goes into the x of the 3D vector. We leave y at 0 because that's already handled in the jump code. And then for the z, we pass data from the y data of the 2D vector, which is now our forward and backwards data. So when we pass that in, and then we just assign velocity of our player to those directions, then we can see we start moving around. Well, we don't, because I didn't uncomment this piece of code. So now we can move around. However, when I press forward, we are still moving in the player's direction, right? So if I press forward, we're still going in that direction. If I rotate the player this way, still when I go forward, it always goes in that direction. And why is that? It's because of this transform basis. And basis is a way of storing data about rotation and scale. You can check the Godot docs for that. But for now, think of basis as rotation. And we are using our player's basis. However, remember when we are moving our mouse, we aren't rotating the entire player. We are just rotating the camera or the spring arm. So if we instead use the spring arm basis, now we are saying, hey, the forward is not in the direction of our player. It's in the direction of our spring arm. When I move forward and look to the side, we are now moving in the direction that the camera is pointing. So now that we've done the movement part correctly, the only thing that's left to do is to orient our character in the direction of the movement. So I will leave this for the next video because this is getting out of hand and I'm starting my vacation in like 2 hours. So I will do that in the next video, and until then, good luck with your deving.